Welcome to the Hoja on Everything. The Space. Chapter 7. The Galactic Power Trip. In the previous episode, we asked one of humanity's oldest questions. Are we alone? We explored habitable planets, biosignatures, and the remarkable silence that still surrounds the search for extraterrestrial life. We also met Enrico Fermi, whose famously uncomfortable question, "Where is everybody?" continues to puzzle scientists today. But let us imagine just for a moment that somebody eventually answers. Suppose intelligent civilizations really do exist throughout the universe. How would we compare them? By population? By technology? By philosophy? By the number of streaming services they somehow ended up subscribing to? In 1964, the Soviet astronomer Nikolai Kardashev proposed an idea that was both surprisingly simple and astonishingly ambitious. Instead of measuring a civilization by its culture, its intelligence, or even its scientific knowledge, he suggested measuring something far more practical: energy. The more energy a civilization can capture and use, the more technologically advanced it is likely to be. It is, in many ways, the ultimate electricity bill. At first, that may sound slightly disappointing. We like to imagine advanced civilizations discussing philosophy, composing magnificent symphonies, or uncovering the deepest mysteries of the cosmos. Kardashev quietly replied, "Very nice. Now how much power can they generate?" It turns out that every civilization, no matter how sophisticated, eventually encounters the same problem. Everything requires energy. Cities require it. Computers require it. Spacecraft require it. Even making coffee requires it, which immediately explains why civilization itself occasionally feels rather fragile. Kardashev therefore divided hypothetical civilizations into three broad categories. A Type 1 civilization can harness the energy available on an entire planet. A Type 2 civilization controls the energy output of an entire star. A Type 3 civilization can utilize the resources of an entire galaxy. The numbers sound less like a scientific classification and more like the levels of an exceptionally ambitious video game. So where do we fit? Rather awkwardly, somewhere below the beginning. Humanity has not yet reached Type 1. According to modern estimates, we currently rank at roughly Type 0.7. That is a wonderfully scientific way of saying still under construction. We have learned to split atoms, send spacecraft beyond the solar system, and communicate instantly across continents. Yet we still occasionally lose electricity because somebody accidentally dug in the wrong place. Perspective, once again, is healthy. Reaching Type 1 would mean using almost all the energy naturally available on Earth: sunlight, wind, oceans, geothermal heat, and every other practical source our planet provides. We are making progress, but rather unevenly. Humanity occasionally resembles a group project in which several students are working extremely hard, while others are still arguing about whose turn it is to plug in the laptop. Of course, reaching Type 1 is not simply about producing more electricity, it also means learning to use energy far more efficiently, wasting less of it, and distributing it more intelligently. In other words, becoming an advanced civilization may require better engineering just as much as better science. If Type 1 is about mastering an entire planet, an obvious question follows. Once a civilization has learned to power a world, why stop there? If a Type 1 civilization learns to use the resources of an entire planet, a Type 2 civilization thinks rather bigger. Instead of relying solely on one world, it begins harvesting the energy of its parent star. At first glance, this sounds like the sort of idea somebody proposes after far too much science fiction. Surprisingly, however, the concept has genuine scientific roots. In 1960, the physicist Freeman Dyson suggested that an advanced civilization might eventually build enormous structures around its star in order to capture a significant fraction of its energy. Before anyone rushes off to buy industrial quantities of steel, it is worth clarifying one thing. Dyson never proposed a giant solid shell completely surrounding a star. Popular culture rather enthusiastically added that detail later. His original idea was much more realistic: a vast swarm of satellites, habitats, or power-collecting structures orbiting the star together. Science fiction looked at the proposal and, as it often does, politely replied, "Let's make it much larger." Incidentally, no, this is not the same Dyson famous for manufacturing vacuum cleaners. However, both Dysons are, admittedly, remarkably interested in collecting things. The engineering challenge would be almost beyond imagination. Humanity currently celebrates building large bridges, tunnels, and space stations. A Dyson swarm would require dismantling enormous numbers of asteroids, moons, or even planets to provide enough construction material. At that point, project management becomes slightly more complicated than updating a spreadsheet every Friday afternoon. Even if such structures are far beyond anything humanity could currently build, astronomers have already searched for possible Dyson swarms around distant stars. So far, nothing convincing has been found. Even so, the search itself reminds us that science sometimes looks for ideas long before it expects to find them. If you've ever played a resource management game, however, the logic may already feel familiar. Whether it is Starbirds, Factorio, Dyson Sphere Program, or countless city-building games, the pattern is always the same. You expand. Expansion requires more energy. More energy allows further expansion, which in turn demands even more resources. Apparently, both game designers and astrophysicists eventually discover the same universal truth. Sooner or later, everything becomes an energy problem. Science fiction has explored these ideas for decades. The Galactic Empire in Star Wars certainly behaves as though it has access to extraordinary amounts of power, although building planet-destroying battle stations may not represent the most efficient use of one's energy budget. Dune, meanwhile, reminds us that the control of a single vital resource can shape entire civilizations. Kardashev Scale replaces spice with electricity. It turns out that the future may depend less on who controls the rarest material and more on who can keep the lights on. Yet even an entire star provides only a tiny fraction of the energy available within a galaxy. If one civilization could somehow learn to harness not one sun, but billions of them, the scale would climb to a level that stretches almost beyond imagination. A Type 3 civilization would no longer think in terms of stars. It would think in terms of galaxies. Instead of harvesting the energy of a single sun, it would somehow harness the energy of billions of stars spread across an entire galaxy like our own Milky Way. At this point, the numbers become so enormous that the human brain quietly stops calculating, nods politely, and hopes nobody asks for the electricity bill. From our perspective, such a civilization would appear almost godlike. Yet Kardashev's scale says remarkably little about intelligence, morality, or wisdom. A Type 3 civilization is not necessarily kinder than we are. It is simply better at managing energy. That distinction is worth remembering. History has repeatedly demonstrated that technological progress and good behavior are not always close traveling companions. Naturally, science fiction has been fascinated by these ideas. The Galactic Empire in Star Wars spans vast regions of the galaxy, while the great houses of Dune control thousands of worlds connected by trade, politics, and technology. These stories are not scientific predictions, but they help us imagine the extraordinary scales that real astronomy occasionally invites us to consider. Fiction asks, what would such civilizations be like? While Kardashev asks a simpler question, how much energy could they actually use? You may occasionally hear people discussing Type 4 or even Type 5 civilizations capable of harnessing the energy of the entire observable universe, or perhaps multiple universes. Those extensions are fascinating thought experiments, but they were never part of Kardashev's original proposal. Scientists generally stop at Type 3, not because imagination suddenly fails, but because evidence politely does. And where does that leave us? Somewhere around Type 0.7, still arguing about renewable energy, charging cables, and whose turn it is to pay the electricity bill. That may sound rather modest compared with galaxy-spanning civilizations, but perspective matters. Humanity has traveled from discovering fire to landing spacecraft on other worlds in only a few thousand years. Cosmically speaking, we have only just learned where the light switch is. Fortunately, no civilization has yet reported problems with customer support. Perhaps that is the real lesson of the Kardashev scale. It is not a prediction. It is not a promise. It is simply a reminder of how much larger the universe may be than our imagination comfortably allows. Whether any civilization has ever reached Type 2 or Type 3 remains completely unknown. We have not found a Dyson swarm. We have not detected a galactic civilization. For now, they remain fascinating possibilities waiting for evidence. In the next episode, we will discover that even the most advanced civilization imaginable still faces one unavoidable limitation: time. Stars do not shine forever. Galaxies continue to evolve. Even the universe itself has a future. We will explore the distant fate of our solar system, the possible endings of the cosmos, and perhaps ask the biggest question of all, whether even the greatest civilizations must eventually face an end. This concludes Chapter 7 of The Space, the Galactic Power Trip. Thanks for listening. See you in the next episode.